So thank you very much for having me. It's always a pleasure to be able to talk about the company and describe what we do. And as said, we are a technology company. We are out of Göteborg, even though I have a Skånsk Swedish accent, which perhaps is not visible in my English, hopefully. Anyways, so we are still a pre-revenue company. We are in a very strong development phase, commercializing our technology. And I usually say that Smoltek sits very well in time with respect to the technology development that we see around us, with ever-increasing requirements for performance, while at the same time everything is to be cheaper, smaller, more effective. And that requires new innovations, requires new disruptive technologies, and that is actually what Smoltek aims to help out with. So what we do, I got the introduction, you made it very well, so I will not dwell too much, but we can make materials and components thinner, more energy effective, more powerful, cheaper, and we do this by growing three-dimensional structures of carbon nanofibers that basically multiplies the addressable area which we can coat with different type of materials on the substrate in order to make it more effective. And thus we solve very advanced materials engineering problems. And as you can see on this slide, even though it's rather small, there is a lot of areas that we can address, everything from capacitors, as we are doing, hydrogen, what we are doing, but also in other areas like medical components or what have you. So, but for a small company like us, we need to focus, and we have chosen to focus on these two areas: semiconductors, where we develop ultra-thin capacitors, where the capacitor manufacturers are the intended target customers for us, and in the space of hydrogen, we develop a high-efficient cell material to enable more cost-effective production of fossil-free or green hydrogen. And those are the two areas that I will describe to you in this presentation. So if we venture into the capacitor side, the global capacitor market, first, capacitors are small fundamental units that are needed in all electronic components, basically to stabilize the power in the device. And this is a humongous market with applications for very many different purposes. It's also a rather stable market, it's growing stably, but it's also looking at change. And the change comes from the development of advanced semiconductor circuits that requires a new generation of highly advanced capacitors. And this comes back to what is called the Moore's law, basically. If we look at Moore's law, in 1970 we had 1,000 capacitors on a chip. Today we have 50 billion. And this trend is ever increasing. And we are now in this upper quadrant that you can see here. So basically the need is already there. And traditional capacitor technologies more or less have come to an end to be able to support this development. So basically you could say that Moore's law has created a need for a highly advanced and new type of generation of capacitors. And that is where Smoltek comes in, because we can create extremely high electrical performance in an extremely small form factor. That is the key here. And that means that the capacitors can be placed very close to the chip. If you look at that slide up there, or the picture up there, you see the traditional MLCC type of component. It cannot be much closer to the chip than what it is. Our capacitor can be placed more or less everywhere around the chip. And that is the key to get the performance from the new chip technology, to benefit from it. Otherwise you cannot. And so basically you can say that without technology you can actually meet the requirements of the capacitor industry, of the chip industry, with respect to high capacitance, with respect to low electrical losses, but also we can create the thinnest capacitor there is. We already have a prototype which has been displayed, I think actually it was last year, which is only 40 micrometer high, which is basically half a hair. You can barely not see it. And it's still a prototype, so it's not done in industrial context, but that is exactly what we are now doing, industrializing this process and able to supply it. And actually, in that slide, you cannot see it basically, but it's 540 micrometers, but the active capacitor stack is just 10. The rest is silicon. And we also have technologies that are under development that they enables us to reduce the silicon, which means that we can make an ever lesser or thinner capacitor over time. So we are very much in line with what is happening with Moore's law and the requirements of the industry through our technology. And that is what makes it so special. And obviously the placement, as I said. So, and this type of circuits, these advanced chips, they are not just for perhaps the mobile industry, which has actually been the driving force behind this development of these advanced chips. You find it in Apple phones, you find it in Samsung phones. But also other industries will absorb this type of technology, which makes the market extremely potentially large for us, and it is technology. So what we are now doing is that we are having our first product within this space. It's going to be an ultra-thin decoupling capacitor, and the aim is to be placed close to the application processor in a cell phone. That is more or less the premium target, and as I said, this is the market which has driven this type of development. And it is a rather large market. It's a premium market, but still rather large, about 12 to 15 billion pieces or units per year. And it is growing. And as you can see in the slide here, that is a Snapdragon processor, the generations from 2020, 2021, and 2022. You can see that the number of capacitors attached to the chip is growing. And we foresee that this trend will continue also going forward. And we obviously aim to capture a rather significant share of this market through our technology, and not the least through the collaboration we have with our partner. Because obviously being a small company from Gothenburg, entering into the semiconductor business, that is not an easy task. You need to have somebody to rely on, to help you out, to drive the business together with you. So we have struck an agreement with a Taiwanese US company called Jiazhou Group, one of the key players in the industry actually. You can see some data about them on the right-hand side here. They are turning over about $4 billion a year, 45,000 employees present globally, also here in Europe. 47 sales offices, 49 production facilities, 20 R&D labs. So a rather substantial player. And what we have done is that we have now an agreement with them, basically two agreements. One is a memorandum of understanding, which says that we are going to commercialize this technology, but we're going to do it in two phases. The first phase is a joint development agreement, which we are now in. It was signed in August, where we developed the technology together and in the industrial processes. When we, pending certain achievement of certain metrics, then we will form a joint venture where we together will produce and sell capacitors to the market, to basically customers that already Jiazhou has during its course or its business. Because they are addressing this market already, but they are not addressing these specific segments. So for them, this is a revenue expansion opportunity to get into spaces where they are not today. And obviously also to improve on the actual products and markets where they sell today. So this is a fantastic opportunity for us because they are the perfect partner in a sense. They have the industrial competence, they have the ability to help out in the development phase of the technology, but also do have sales, marketing, and the channels and the operational structure to actually be able to supply into this highly difficult, I would say, in complex market. So for us, this is both a proof point that the technology we have is actually worth something, having, but also that we are, in a sense, disruptive, that we can actually make something new, which can create a new position for them. So the key activities going forward, as you can see here, it is obviously to execute under the joint development agreement, getting industrially manufactured engineering samples to the market so we can start interacting with customers, their customers, with respect to final design and performance requirements and so forth. It's always a long process, especially when you are in this kind of industry. and also setting up the, so to say, the manufacturing infrastructure. For obviously we are not building a factory. We are utilizing already existing CMOS infrastructures in order to actually produce our capacitor. What we add is the unique component that we own and the technology that we own, that is how to apply the carbon nanofibers to this product. So, from that point of view, if you look at the semi business, it's rather well positioned. We have the technology, we have done some proof points, we have the partner, so we have a clear path to actually take the product to market. The other market that we are addressing is hydrogen, and this is a more or less nearly unfathomable market in size in terms of hydrogen is going to be used in every context, basically. I mean, from a perspective of climate neutrality, getting rid of carbon monoxide and so forth, hydrogen is a powerful source of energy to the world community, basically. And you can see the numbers here. They are so humongous that you can not really understand them. But still, the problem here is that the cost of producing hydrogen is still too high. And that is going to be an inhibitor to the usage of hydrogen if that cannot be reduced. And that is where our technology comes into play with respect to what we call high efficient cell material for electrolyzers, where we can actually contribute to reduce the cost of producing green hydrogen. And obviously, that's a great potential for us to take a significant share of this market. I can also say that from a development perspective, we are not as far here as what we are on the semi side. So we are still working on more core technology here than what we are doing on the semi side, but still. What we are focusing on is, as I said, a high efficient cell material for the anode side of an PEM electrolyzer. That basically can reduce the cost of producing green hydrogen. And as I said, this is the key to get hydrogen into the market, that it becomes cheaper to produce. The PEM electrolyzer is interesting in the sense that it can utilize what one call intermittent type of energy sources like sun, like wind. So they can work with those. But the downside of it all is that it utilizes a number of very, very expensive catalyst particles in the process of actually producing the hydrogen, like iridium. Iridium costs about 1.2 to 2 million Swedish krona per kilo. So obviously there's not a humongous amount that needs to be utilized every time, but still it's a very large cost, and iridium as such is also an extremely scarce resource. And as the PEM electrolyzer does not use it effectively, by utilizing our technology, we can actually maximize the usage of the iridium and potentially reduce the amount of iridium that is needed by well over 80%. We can also help improve the current density, and that means that the electrolyzer can be substantially smaller. And if you say that an electrolyzer plant costs about 600 million Swedish krona to establish, if we can reduce that by 2-3 times, then obviously there is a financial opportunity here, and also an opportunity to reduce the cost of production of green hydrogen. So basically, utilizing our technology, increased efficiency, reduced cost, and no unnecessary losses. So, well, let's go back. So our ambition here, similar to what we do within the semi side, is that we obviously need a partner to take this to market, because otherwise it would be a too difficult challenge, basically. So we want to more or less mimic the setup that we have within the semi business now with Yageo, but also in this piece. And we do have collaborations already existing today. One collaboration, important collaboration, I would say, with the component supplier to the electrolyzer industry, where we are doing development of the cell material as such, to be enabled to create demonstrators to show the performance that we actually can deliver with our technology. We're also having a collaboration agreement with one of the leading European electrolyzer manufacturers, where we will apply our material to an existing cell layer in the electrolyzer cell to evaluate the technology as such. So two very important collaborations that we hope can take us a little bit to the next level with this technology. So with that, what is focused now is to fabricate demonstrators to be able to show the best combinations of the material, but also do tests and long lifeline tests and so forth on the technology to prove its value to the electrolyzer and to the hydrogen community as such. We have put a stake in the ground and said that this company will have substantial revenues in 2027. And obviously, when we have done these estimates, we have been rather conservative, given the fact that they are a bit out in time, both with respect to the addressable market, but also to volumes. But we feel that given the processes we're in, the plans that we have, this should be an attainable, achievable target for us. And also we see that there are a lot of other type of future product areas that we can address with the technology platforms and the product platforms that we now develop in adjacent areas to the two target segments that we are now addressing. So what are the reasons to invest in Smoltek? Yeah, well, we have two business areas with very strong growth potential where we basically can be an enabler for growth. We have very well defined both short-term and mid-term plans in order how to get there. We have an experienced management, I would say, and board that has done this kind of journeys before. So we are doing it a little bit again. And we have the partners that actually can take us to market, especially within the semi side, to really commercialize this technology. And we see a lot of other types of opportunities very close to where the technology is today that we can utilize and, so to say, create additional growth. So we are on a very exciting journey. So that's like what Stordalen says, we all long for the Monday in our company. So thank you. That is what I had to say.
Thank you very much indeed, Håkan.
Thank you.
You touched upon the topic of raw materials, especially for the semiconductors. How about scarcity? How about price increase in the current global situation? How is this affecting you?
Not at this moment, because we are in a development phase, and basically I would say that what we do will potentially help in that aspect, as well as we're adding to, so to say, something. And but I mean, from the raw materials point of view, it's basically on the hydrogen part, it is the iridium that is the scarce resource. It's difficult to come by, and it needs to be used extremely efficiently if you are going to reach this point where hydrogen is to be used as a commodity, basically for energy consumption.
What is your take on policy in hydrogen? Because we know many governments are now looking to hydrogen as a big part of the solution. Do you foresee any let's say contributions from policymakers in terms of facilitating this transition?
Yeah, it's already happening. I mean, the EU is, I think, it's 50 billion euros that are now putting into this space. So, and every government is basically trying to help to get hydrogen into the system, so to say, in most countries. I think what the most of the money today goes into actually producing with the existing technology. I don't think there is that very much money going into looking into advanced new technologies, improving the present technology. But I hope we will see a change there.
So are you looking at any specific, I'm thinking about the EU Innovation Fund, for instance, there's money there to be found?
Absolutely. So we are scouting all these opportunities and have people who has a long experience from dealing with these bodies. The problem is it takes quite some time.
Indeed.
There's lengthy processes, complex applications, and so forth. So that is something that could be
But if you look at the hybrid, the 142 million euros they've received, and also the hybrid, the Stockholm Exeter, the 188 million, there is money to be found.
Absolutely. So we are looking at that as well. It's
Well.
important for us. Obviously, we need to fund this.
Of course, you need also investors.
So
That's primarily why you're here, of course.
absolutely.
Well, best of luck.
Okay.
Very interesting presentation. Thank
Thank you very much. Thank you.